Hi, welcome back. In today's video, I am going to show you how to graph polynomial function in standard form. Okay, so first, you're going to list out the key features. So let's start with the degree. Okay, the degree here is represent. So the polynomial is already written in standard form. So the highest exponent is the first exponent. So it's going to be is 3. So the degree is 3, but I just want to find out if it's odd or even. Since 3 is an odd number, I'm going to write odd. And SOTLC stands for sign of the leading coefficient. So here, the leading term is x cubed. So the leading coefficient is the number in front of x cubed. So what is the number in front of x cubed if you don't see it? Okay, it cannot be 0, it has to be 1. So it's positive 1. Okay, so because you cannot see, there's no negative there, so it's positive. And let's then describe the end behavior. So to describe the end behavior using arrow notation, so let's do a visual, okay, representation of end behavior. So because the sign is positive, so the arrow on the far right is going to point up. And since the degree is odd, so the odd degree polynomial point toward opposite direction, so it's going to be like this, okay? I know the other end needs to point down, okay? So on the left side, as x approaches negative infinity, what is happening to the y value? The arrow is pointing down, so the y approach also negative infinity. So on the right, as x approaches positive infinity, what is happening to the arrows to the y value? The arrow is pointing up, so the y approaches positive infinity. So the y-intercept is going to be the number by itself. We call that a constant. And like you can see, the constant here is positive 6. And if there's no constant, it will be 0. The y-intercept will be 0. Or basically, it's when x is 0. So if you plug 0 into the x, everything cancels out except the 6. Okay, so now let's find the zeros. Okay, to find the 0 means you need to set y to be equal to 0. So the entire polynomial is equal to 0. Okay, and now let's factor. I know in the previous video I showed you how to factor using the by grouping or using the box method. Here we cannot use the box method or by grouping. Okay, why? The reason is simple. I hope you're able to see that. Okay, so when you fill in the boxes every term, okay, to its corresponding space inside the box, what do we notice? Okay, the first row, the greatest common factor, you may see is x squared, but and here you see, okay, there's no common factor, so the only number must be -1. Okay. However, when you go to the column, you want to factor out the first column. What do you notice? Okay. Again, it cannot be factor. Okay. It's if you use here for x, we see that -1 times x is -1x, not 5. Okay, so if I use here then 5x, so x squared times 5x is 5x cubed, not x cubed. Okay, but -1 times 5x is -5x. But okay, so you cannot use grouping of the box method here. Okay, and one way you could have noticed it is you're going to look at the coefficients of the first two leading terms, which is going to be 1 over -2, right? The coefficient here is 1 over -2. So if you do the ratio of the coefficient of the first two terms, okay, is it going to be equal to the ratio of the last two terms, which is -5 and +6? So are those equal to each other? Are those two fractions the same? As you can see, they are not the same, right? So that's why we know that you cannot use grouping of the box method. If the ratio were the same, you could have used grouping of the box method. So let's continue. So you're going to ask us, okay, how do we find a 0 then? If you cannot use grouping, factor by grouping, or using the box method, that's when you're going to use the rational root theorem. Okay, so what is the rational root theorem? So the rational root theorem allows us to list all the possible solution of the polynomial. Okay, so you always want to start with the x and then equal the plus and minus sign. You're going to draw a fraction line, and on top you're going to list all the factors of the constant. So for our polynomial, the constant here is the number by itself, is 6. So you want to list all the factor of 6. The factor of 6 in a correct order. Is what are the factor of 6 in the correct order? So I mean from low to high factor. So you have 1, then 2, 3, and 6. Okay. So what do I get? 6. 6 represent the constant. So you want to list out the factor of the constant. Now, below the fraction line, you're going to now list the factor of the leading coefficient. The leading coefficient is the number in front of the leading term, which is here 1. If you don't see the number, it's not 0, but 1. So what are the factor of 1? It's 1, okay? It's not 1, comma 1. So you only repeat the factor once, okay, if they're the same. So it's just 1, okay? So now it's going to be the ratios of the factor of the constant over the ratio of the factor of the constant and the leading coefficient. And the factor of the leading coefficient. Okay, so after dividing each number by 1, I end up with plus minus 1, 2, 3, and 6. Again, we list all the possible solutions for this, all possible rational solution for this polynomial. And again, they are not just 4, they are 8, because you have to consider positive 1, positive 2, positive 3, positive 6, as well as negative 1, negative 2, negative 3, and negative 6. So now we list all the possible solutions, but not all of them are solutions. So what do we do next? That's when you're going to learn, you have to use another method, which we call synthetic division. Okay, so you're going to use synthetic division to find out which one are solutions. So I'm going to start with positive 1 first and check. So at 1, so you're going to draw L shape, something like this, right? L shape, okay, like this, or half of the rectangle on the left. Then on the same level as a 1, you're going to list out the coefficient of the polynomial. Okay, you're going to list out the coefficient of the polynomials. And if an exponent were missing, you're going to use 0 as a placeholder for the missing terms, exponent. So you want to start with 1. The first coefficient is 1, after it's negative 2, so I'm going to write negative 2, then negative 5, and then positive 6. Okay, all set. So now to do the synthetic division, okay, you're going to bring down the first leading coefficient right here, which is 1. Then you're going to take the 1 and you're going to multiply with the 1 on the side. I call that the divisor. So you're going to multiply. So you're going to multiply. Okay, so let me multiply. 1 times 1 is 1. And the product, you're going to write it below the negative 2. So you get 1. And then you're going to add. Okay, you're going to add vertically. Negative 2 plus 1 is negative 1. Then you're going to take this number and then multiply with the 1 right here. So negative 1 times 1 is negative 1. And I'm going to write negative 1 below the negative 5. And again, you're going to add. You're adding. So negative 5 plus negative 1 add up to negative 6. What do we do next? Okay, you got it right. You multiply with the number on the side, the 1 here. Negative 6 times 1 is negative 6. Then you're going to add, and you end up with the 0. And the remainder here is 0. Because the remainder is 0, okay, it's telling us that the polynomial, the solution x equal 1 is the solutions of this polynomial. Okay, of this polynomial right here. Okay, another way you could also verify if 1 is a solution. Okay, you could just plug into 1 into the x and find out if the expression, the polynomial, is equal to 0. Because remember, to find a 0 is when the y is 0. So if the output is 0 when x is 1, it means, okay, 1 is an x-intercept. So let's do that right here. Let's evaluate the polynomial when x is 1. Okay, so as you can see here, when 1 minus 2 minus 5 plus 6 add up to 0. So correct, when x is 1, his output is 0, his y value is 0. So x equal 1 is the solutions, okay? So it's a 0. Now, what do we do next then? We find 1, 0. Remember, the number of degree of the exponent tells us the number of solutions. Okay, from the polynomial here, the degree is 3, so I know we have 3 solutions, okay? They can be real or in complex conjugate, but in this example, they're rational numbers, okay? So how do we find out the 2 remaining one? We found 1, how do we find the other? So that's why I like synthetic division, because as I told you, the number listed here represent the coefficient of a new polynomial, okay? Okay, so we know that x equal 1 is a solution. And to write x equal 1 as a factor, all I have to do here, so you have x equal 1 and you want to write it as a factor. You minus 1 on both sides and you end up with x minus 1 equals 0. So the first factor is going to be x minus 1 times and equal to 0. So the second factor, okay, is going to be, so the first coefficient of the second factor is going to be 1, okay? Now, the variable I'm going to use is going to be x squared, because it's always going to be a degree less from the original degree. The original degree is 3. So to complete the second factor here, it has to be a degree less, okay? Remember, because you pull out the x already, factor out the x. So it has to be x squared. So you end up with 1 x squared minus 1x and negative 6, like this, okay? So again, the coefficients are listed right here, okay? So I just replace, so I make sure I put 1 in front of x squared, negative 1 in front of x, and negative 6 is a constant. So in mathematics, we don't usually write multiplication of 1, so I'm going to drop it, okay? So then I'm going to ask myself, okay, is it quadratic expression factorable? What do I mean by factorable? Can you think of two numbers that add to negative 1 and multiply to negative 6? So always start with the product. Can you think of two numbers that multiply to negative 6 and add to negative 1? Correct. The two numbers that work is going to be, the only two numbers, negative 3 and 2. Okay. So now, I'm going to rewrite the first factor, x minus 1 times, because the coefficient of x squared is 1, I can just write two empty factors like this. Okay, and inside of it, I'm just going to write the missing number, the two new found number, negative 3 and positive 2. That's it. So don't forget to make it equal to 0. Then you're going to apply the 0 product property. You're going to take each factor and set it equal to 0. And then you're going to solve for x. Okay, here are the x-intercept. And remember, those solutions are single. Okay, there's no number being repeated, no x-intercept being repeated here. Okay, so you have three single roots. So the polynomial is going to cross over the x-axis at negative 2, positive 1, and positive 3. Okay, so the domain for every polynomial is always going to be all real numbers. And in interval notation, this is interval notation. The range for the odd degree polynomial, the range will always be all real numbers. It's not true for even degree. It's only true for odd degree polynomial. Okay, and here is a graph I sketched earlier. Okay, so we know the x-intercept occur at negative 2, positive 1, and positive 3. The y-intercept is 0,6. Okay, and I know that the relative extrema occur in the middle between the zeros. So I have one at negative 0.5, and I wanted to evaluate the y value is about 7.8. And what I've done is I count 8, and I make sure at negative 0.5, I want just a tiny bit below 8. Okay. Then the second relative extrema is at 2. So when x equals 2, the y value is negative 4. So I already done the computation right here. When x is 2, the y value is negative 4. Okay. Then after that, I just include the end behavior on my x and y coordinates as a reminder to start from the bottom, cross over the x-intercept. Okay. connect with the first relative extrema, the y-intercept, cross over the second x-intercept, connect the second relative extrema, and cross over the third x-intercept. Okay, and always include the errors on both ends of the polynomials. And that's the end. Okay, I hope the video was beneficial to you and you learned a lot. So thank you for watching my video and have a wonderful day. Bye bye.